Hey, what's up guys? It's Nicola from Calcunic, and today we're going to be talking about a really cool coding and math technical interview question. Let's get right into it. So our question goes as follows. Given a function that outputs a number from 0 to 1 randomly, calculate pi. And at first glance, this seems pretty overwhelming, which will probably be the case for most coding technical interview questions. However, you need to remember that these interviews don't go for that long, and so therefore the solution to this question can't be that long either. Essentially what we're asked is to find a relationship in between this random function and pi. And usually when I'm stuck in a situation like this, I like to take a geometric approach. We know that pi comes up really often with circles in geometry, and that the area of a circle is equal to pi r squared. So now it's up to us to find a way to express this function that gives a number from 0 to 1 randomly in geometric terms. So here we have two number lines, both from 0 to 1, and the square that it encapsulates. And notice that if we run this function twice, we'll get a number here, say around 0.6, and a number on the y-axis, say around 0.2. And this gives us a corresponding coordinate in the square. Notice that if we run multiple trials, we'll get a bunch of other coordinates in this box. Now, we somehow want to add a circle to this picture so we can establish a relationship in between pi and the function. So on top of the box we had before, we've drawn the unit circle, or just a circle with radius 1. Notice that each time we do the function twice, we'll get a coordinate in the box, which we knew before, but now we'll also have another property. We could count how many of the coordinates land inside the circle or in the purple area, and how many don't, or just in the yellow area. And so if we wrote a program to run the random function multiple times and then record how many times the generated coordinate would land in the purple area, or right here, we would get a number that is pretty close to the division of the area of this sector with the total square. Lucky for us, we actually know these areas. So the purple area is just a quarter of the area of the circle, and as the radius is 1, we have that the area of the purple sector is equal to pi over 4. And this is all over the area of the square, which is 1 squared, or just 1. And obviously this is equal to pi over 4. And this proportion will be equal to the trials and purple all over total trials. And so if we multiply both sides of the equation by 4, we get that pi is equal to 4 times trials in purple over total trials. Now that we have the hard part out of the way, establishing a relationship, let's talk about how we would actually write this computer program. Alright, so here we're going to write a quick Python function. So we're going to import these three libraries, sys, math, and random, to help us write our code, and we're going to define a function, and we're going to call it estimatePi. So we can start off by writing a variable trial successes, which is going to be equal to 0, and we're going to use this as a counter to keep track of how many successes we've had. So let's get into our loop that's going to calculate this. So we have a for loop, works with a range, which is the number of trials, and we're going to define two variables here, the x coordinate, which is just going to be, we're going to take a random number from 0 to 1. And it's the same story for the y coordinate, just a random number from 0 to 1. And so now we're going to define the distance of the point made using the x coordinate and y coordinate from the origin is going to be the square root of the x coordinate squared, plus the y coordinate squared. And we're going to have a if statement. If the distance is less than or equal to 1, in that case, the trial successes goes up 1. And so as mentioned before, to estimate pi, we're going to do 4 times the probability, or 4 times the trial successes over trials. We'll define a variable, pi estimate, which is going to be equal to 4 times the trial successes all over the trials. And then we're just going to print pi estimate. So let's try and test this out and see if it actually works. So I've just added a little testing framework. I've added an infinite while loop to test as many times as we like, and we're also going to get the number of trials from the user. So let's go ahead and run a command to test this out. So let's see the number of trials. Let's try with 100 first. We get 3.2, pretty close to 3.14. Let's try a bit more. We'll go with 1,000. 3.192. Closer, but still a bit far off. Let's try a bigger number. We'll go with 100,000. 3.144, getting pretty close. And we're going to try now with 1 million. And we get 3.141629. Really close to the actual number pi, 3.1415926. And so we could confirm that this function does in fact give a pretty accurate estimation for pi. If you made it this far, thank you so much for watching. And again, if you had any questions or other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you like what you saw, if you feel like you learned something, or you just thought that you saw something cool, consider leaving a like and a subscribe. It would really help me grow my channel. That's all from me. Till next time.